Okay, in this video we're going to talk about Unit 4 Objectives 1 and 2. Unit 4 Objective 1 is increasing and decreasing functions. So increasing is exactly what you would think it would be. Increasing is when your function has a positive slope. So your function has a positive slope, and it's not a big surprise then that your decreasing means that your function, positive slope, there we go, function has a a negative slope for decreasing. So if we look at the graph that we have up here, this function is y equals 1/3 x cubed minus x squared minus 3x plus 6. If we look at this function, we can see there are two places, two sections, two intervals where our graph is increasing. So if we go and look, we can see that this part here, my function's increasing, its slope is positive, and then again from here to here, my function's increasing because its slope is positive. And in between there, we have a spot where our function is decreasing because it has a negative slope. And if you look really closely and you think about when we were graphing derivatives, where the function changes from red to blue and then back to red again, you'll see that right there and right there, you have places where your derivative is actually 0. So at those points, you're neither increasing nor decreasing. Now, AP is going to like to ask where this function y is increasing, where this function y is decreasing. And the way that we're going to do that is we're going to think about the derivative. Because if we look at our definition of increasing and decreasing, it deals with the slope of the curve, and we know that the slope in calculus is the same thing as the derivative. So what we want to do is start with our derivative. So y prime is going to be, drop your 3 times 1/3 is 1, x squared minus 2x minus 3. So that's our derivative. That's how we're increasing, decreasing. That's the positive nature, negative nature of our slope. But if I want to know when x squared minus 2x minus 3 is positive or negative, I need some sort of anchor point. I need to know when is my function positive, when is my function negative. So let's think about when my function's actually 0, and that's going to allow us to come up with when our first derivative is positive or negative. So if we set our first derivative equal to 0, so we'll get 0 equals x squared minus 2x minus 3. We can factor that, and we can say x minus 2 and x plus 1 is going to be that function factored out. So if we set that or equal to 0 each piece, we're going to say that x equals 2 and x equals negative 1. So I know that my derivative has two places where it is 0. And if we look at the graph, it says x equals negative 1. If we look, we have an orange dot at x equals negative 1. X equals 2 is the other spot. If you look, oops, I'm sorry, that should be 3. Oops, x minus 3. And x plus 1. X equals 3, we'll see another orange dot where our derivative is 0. So how we're going to figure out the intervals of increasing and decreasing is we're going to take those zeros and we're going to put them on a number line. So we'll call that number line f prime or y prime or whatever your function's called. Really, we should probably call that y prime. And we're going to say, alright, on y prime, I know I have two places, negative 1 and 3, where my derivative is 0. Then we're going to take a value, any value that we want, in each of those three sections on our number line. So something less than negative 1 we can say is negative 2. Something in between 0 or negative 1 and 3 would be 0. Something bigger than 3 could be 4. You can take any numbers that you want in there. I'm just going to take those ones. Plug those into y prime. So if we take negative 2 and plug it into y prime, we're going to get negative 2 minus 3 times negative 2 plus 1. So that's going to be negative 5 times negative 1, which is 5. Now we don't really care about the number, we care about positives and negatives. So if we go back to our definition, if our slope or our derivative is positive, like we have here, then we know our function is increasing. So I like to put little plus signs up here above so we can see from negative infinity to 1 we're positive. If you do the same thing with 0 and 4, you're going to find out that your derivative is going to be positive, negative, positive on those three intervals. So we can see from our number line that from negative infinity all the way over here to negative 1, my slope is positive, so my function therefore is increasing. If we go from 3 all the way to infinity, we know that the function's derivative is positive, therefore we are increasing. And then in between those, we can see that our derivative is negative, so our function is going to be decreasing. So we would say that the function, we'll kind of write it down here in the corner, the function is increasing on the intervals negative infinity to negative 1 and on the interval 3 to infinity. So that little u in between them just means union. It means it's both of those two combined. It happens on both of those intervals. And we're going to justify that and say, because, not f prime in this case, because we call it our function y. So we'll say our reasoning would be because y prime is greater than 0. We're going to say our function is decreasing on the interval negative 1 to 3. And our justification there would be because y prime is less than 0. Pen's kind of giving out on me. There we go. Y prime is less than 0. So those are our justifications. Those are the two sentences that you're going to need to know for your AP exam when you take your free response and they ask you to justify why something is increasing or decreasing. It all comes back to our definition of increasing and decreasing. Except in calculus, we try to stay away from the word slope. We want to use the word derivative instead. So if we look down in the box down here, we're saying not because the slope is positive or the slope is negative, but because the derivative is positive or negative. So that's the increasing, decreasing. That's objective objective 1 for Unit 4. We're also going to talk about Unit 4, Objective 2, which is concavity of functions. So we're looking at the same graph here. This is still y equals 1/3 x cubed minus x squared minus 3x plus 6. So we're going to be talking about concavity in this section. Concavity is going to be how this thing opens. Does it open up? Does it open down? So if we look at our graph right here in this blue part, if we were to look just at that and we were in Algebra 2 and we said which way does that parabola open, you would say it opens down. In calculus, we're going to say that that's concave down. So if we look at the other part that we're doing here in red, and I said just focus on that, you would say, well, that opens up, so we're going to say that is concave up. So what we're going to deal with this with the calculus is we're going to say concave up is when the function's second derivative is positive. And as you would imagine, concave down is when your function's second derivative is negative. So, to find where we are concave up and where we are concave down, we want to look at our definition. It deals with the second derivative. So we're going to take the second derivative of this function. So a second ago we found out that y prime, the first derivative, was x squared minus 2x minus 3. So our second derivative is going to be 2x minus 2. Now, just like with our first derivative, when we were trying to find increasing and decreasing, we want to find where the function is neither concave up nor down. So if we look at the graph right there at that orange point, we know we're not concave up or down. That's where we transition from one to the other. So we're going to find it algebraically the same way we did increasing and decreasing. So we're going to take that second derivative, we're going to set it equal to 0, and we're going to solve. So if we look at that, we're going to see that x equals 1. So we're going to build our number line. We're going to call it y double prime. We know y double prime is 0 at x equals 1. If we take a number less than 1, say let's take 0, and we take a number greater than 1, let's say 2, and we plug those into our second derivative, we're going to get negative numbers here and positive numbers here. So we know, based on that, that our function is concave down on the interval negative infinity to 1, and our reasoning would be our second derivative is less than 0, and we're going to say our function is concave up on the interval 1 to infinity, and that's going to be because our second derivative is greater than 0. So again, there's your AP justifications. Y double prime is less than 0 means concave down. Y double prime is greater than 0 means concave up. So that'll do it for this video. We'll see you in the next one.